Hopefully it's got the variable separated there. Integrate both sides. This should be a general solution for the first one. Integrate both sides, 1/3 y cubed, 1/3 x cubed. And then multiply by 3 on both sides, just cancel out the 1/3 and make 3c. You can keep the general solution. The next one, so this one would be I get the natural log of y is x squared plus c. Then I have to e both sides. So we get y equals e to the x squared plus c. You then have to solve for c. So when you do that, one thing that you might want to do before that is write this as y equals e to the x squared times e to the c. Might make it easier. And then when you plug in your point, so you get 2e equals e to the 1 squared, so it's e times e to the c. And then you can divide that e over. So we got 2 equals e to the c. Get the c down, we got a natural log of both sides. So we get c is the natural log of 2. And then our answer, y equals, I'm going to go ahead and use sort of this form here. Y equals e to the x squared, and then I'm going to plug it in here. So it'll be e times e to the natural log of 2. And then e and the natural log cancel, so I can push them 2. So our solution is actually 2e to the x squared. Alright, was everyone able to do the homework problems?
I tried, but I think I lost.
Okay.
You lost.
How about you? Yes, did I do it? Didn't know everything.
7 and 9.
Okay.
Yeah.
Alright, so number 1. Let me pull up the problems too. So number 1. I guess number 1, you don't really have to solve for y. Do you guys solve for y on that one? Okay. Yeah, looks like 2. You can solve for y. 3. Yeah, not able to solve for y because it's in the natural log. Guess you could e both sides, but for that person you can do that. Yeah, because you could e both sides and then eventually simplify it, subtract the 1 over 4. So this was in 4, you got to multiply the dx over and then divide and divide. So we get 2 natural logs. And then you e both sides. And then so you get y equals x minus 2 squared times e to the c. And then okay, so a little bit confusing. On number 4, so this is kind of how the answer, you might have left the answer just sort of like this. This e to the c1, or you don't probably just write e to the c. But what we did in this solution is instead of calling this e to the c, we just like, by calling it e to the c1, we then just call this c. And then c is essentially e to the c1. But either form should be fine. Or if you want to say it's just should have probably stated that somewhere. And then 5. Doesn't look too bad. The c is 12, so answer here on 5. You want, let's see, you want the negative square root because the initial condition was a negative number. Y of 2 is negative 4. So it's really like a negative square root. Also, another thing that's just a little bit different is, so in the solutions there, you went and integrated it, but at this step, and this can actually be easier sometimes, is to go ahead and plug in the initial condition here, this step, and solve for c, and then you kind of just start with that, and you just finish solving for y there. You'll get the same answer. Either way, you're going to do this. You would probably just ended up with, like 2c in there, something inside of here. You would, I guess. So if you could have missed that and solved those. But yeah, it was 2c. Negative 2 squared. And then plus 2c. But then you get c is 12, so it's multiplies. Which ones were 7? That was one hard one, Zoe said. 6. Mm-hmm. 6 was a natural log 1 as well. And you end up getting let's e x to the negative 1/3. Alright, let's look at 7. So the solution is supposed to be this. Let's see if we can, I'll fold the problem up and then we can work it back up. Alright. So first thing we want to do is separate the variables. So this becomes 1 over y when we divide, and then just k dt. K is just a constant. And then integrate. The integral of 1 over y is the natural log of y. And this is just going to be kt plus. Go to that step. Okay. And then what you could do, let's do it, we can do it the way in the solutions where you just plug in your initial condition now. So we would get then, this should be the natural log of 100. So the y equals k times 0 plus c. So then c, this cancels, so c is natural log of 100. And then so in solving this, we would get natural log of y equals kt plus the natural log of 100. And then e both sides to get that y by itself. So then y is e to the kt plus natural log of 100. And then you never want to have a natural log inside of an e or vice versa because those should somehow be simplified. So then this is a plus, so we can write this as e to the kt times e to the natural log of 100. And then e and the natural log cancel, so we get 100 e to the kt. And this is actually kind of setting up what we're going to do in the next section, which is exponential.
Isn't there like an e is inside of the natural log?
The natural log of an e.
Okay, Christ.
If that's ever the case.
It's just a
Yeah. Yeah, it works the same way. So like if you have like the natural log of e to the x, it would just be x. Oh, so the t comes from because we're integrating with respect to t. So whatever that variable integration is. Yeah. This was just dy dt instead of dy dx. So it's some change over time instead of some change over x. That's a good question. All right, and then we got number 8. No, that wasn't too bad. Yeah. I think you just had to notice that it dy dx equals x over 2y. And then you just multiply the 2y over and the x over. And then number 9. Okay, so this is an inverse tangent. That's why it's a hard one. Let's try that one. You didn't recognize that was an inverse tangent. All right, so let's take a look at this. Okay, so there's kind of a certain order you have to do this. All right, so in solving this, there's a specific order you have to do it because when you solve a differential equation, it always has to be something times dy and something times dx. Okay? You can't have like an x dy, yeah, minus plus 2 or something like that. Okay. So the order that you do this is important because we got this -1 right here. So the way that we kind of make this work, like the way it's written right now doesn't work because we've got a minus there and it's not touching y or x, right? It's a subtraction. So the way that we need to get around this, let's see. The first thing we should probably do is okay. So first thing we want to do is multiply by the reciprocal of multiply that. Okay. Add it over first. Get out of the way. Let me scroll over so I got a lot more space. This one is tricky. So we're going to add that 1 over first. So then we have x over 2 dy dx equals y squared plus 1. The next thing we're going to do, really these other two steps are mixed or interchangeable, but you have to do that one first. Is we x is over there, and we're going to need to get the y's back over here. So let's just divide this into a few steps. So we'll do times 2 over x to get rid of this. And this will come times 2 over x in here. That whole thing has to be in parentheses. Alright, and then we'll also multiply the dx over. So we can multiply by dx as well. Cancel this one. So this one dx. So all we have left here is dy equals, and then it's y squared plus 1. And this is 2 over x dx. And then we'll want to divide by y squared plus 1 on both sides. So that way, this becomes 1 over y squared plus 1 dy. Well, this is tricky because if you don't do it in the right order, that 1 isn't going to end up being attached to a dy or dx. So you have to do that adding that 1 over first.
Actually, it's not much space in there because when you're doing that kind of algebra, are you supposed to do like reverse converse?
Yeah. So, yeah, so as long as you do it the way that you should, should. But it also maybe isn't clear that you have to add the 1 over there. Yes, people will generally get the y by itself, but it isn't necessarily clear that you have to add the 1 over there. Because you got to add it over and then you bring it back. Okay, so then from there, we integrate. And this is an inverse tan, which we can see by looking at it. You got like the something squared plus something squared in the denominator. So this is the inverse tan, right? Our tan. Y over 1. Yeah. Just dy over 1 is just y. Equals, and this is going to be 2 natural log of x. And then, I guess to get the y by itself, then you can tan both sides, right? Opposite of our tan would be a tan. So then y equals tangent of 2 natural log of x.
Some of the numbers,
Yeah,
there's only one number in there.
that's true, yeah. One more number, the letters come first. So let's see if that's right there. Yeah. Well, I guess there was an initial condition with that one too. -2. Oh, okay. Yeah, so then we could plug this in to get the c. 1 equals the tangent of 2 times the natural log of 1 plus c. The next log of 1 is what? Right. So this just becomes, yeah, so 1 equals tan of C. So then we have to do the inverse tan of 1. So then you have to think, where does, it's a bit challenging. But whenever you have a tangent and it's a 1, yeah. So it's going to, tangent is the x. So you're thinking of where the y over the x, um, yeah, where the y over the x is 1. So it's got to be pi over 4. This could also be 7 plus 7 pi over 4. That one's a bit tricky. So I'll go ahead and pass back the text here. They I say weren't amazing, but I think what made this unit challenging too is it stretched out so long. One, because it was long, and then two, because it was, we had like snow days, and I think we started this right when we got back from. I don't know, but anyhow, yeah, so it stretched out pretty long. It was hard too, but. Is there, take a look through, if there's any specific ones that you want me to go over, I'll be happy to do that. We already went over the calculator section. So a lot of people miss points on this page, which was the front of page 2. There was a lot of on there. A lot of people were thinking, I think I remember 37. A lot of people thought 37 was an inverse sine, I think. At least one or two did. The reason why it's not an inverse sine is because there's an x up there. So it's actually just a u substitution. They're tricky. When you see them all mixed up, it's a little more challenging. There's no long division. In the back page. The related rates was pretty easy, related rates, but some people just forgot how to do that when you do the implicit differentiation, because you have to do a product rule when you do the derivative, and then so it's like 1 times dy dx, and then plus that is a step here for implicit differentiation. And this last part was pretty bad too. So you had to find the first derivative, find the critical numbers where it was 0. which was only at x equals -1, if e to the x would never be 0. And then so we are increasing and decreasing intervals. There's no relative max, there's a relative min because it goes from decreasing to increasing. Then I did the second derivative, which was a bit challenging. I think I was doing the only grading for that. And then the inflection points is what they're called. This is the second derivative, we're just at -2. And then so we got the concavity. There was an inverse sine, arc sine here, which 41 was. And the reason why it is this doesn't happen very well.
I feel like I'm not familiar enough with natural arts and views, and the more esoteric things.
Yeah. Yeah, when you don't use them a lot, it's hard to be confident with them. So maybe that's something we can review a lot. I was just looking through, like, there's a ton of extra materials too. So this unit is really short, and then we'll have the other one. And then there's all kinds of extra review materials that are included with this textbook.
I'm sure that I think just more.
There also is there actually this just got updated this week into the Dropbox. I get like a little notification when the guy adds stuff to the Dropbox, and there was what was it that he added? He added more practice with the long division and one other one as well. Yeah, I saw this one. There's a lot of review materials in here. Oh, here it is, review assignment. So he added this long division and completing the square assignment. This is, I think he realized that was kind of lacking in the problems. Remember when we did that and it was like there's not even really any problems over that. So he just added that, I think, over this past weekend. Some more practice on doing that. But this is also one of those things where it's probably not going to be a big part of the AP test. So like, do you really want to spend another day doing this when it, you know? So you just kind of got to balance that stuff. But I was looking more through the review materials, actually some yesterday, and there's actually tons of extra assignments, and the whole review packet. I'll show you how long it is. So we'll eventually get this, but it has like all of the. So I'll give you this. Yeah, it has everything you really need to memorize on it. And then it has just some other tips we'll talk about. And then just like pages upon pages of review stuff. So just pages of old problems, things like that, which we'll review. Free response ones, which we haven't got to do a ton of the free response ones, so we'll do some of those. But all in all, it's this is 98 pages, so this will be a good review resource for we'll do after
I guess one of the reasons, because I've noticed, remembering the derivative part is getting harder and harder as we go along.
Yeah.
I guess it's just because of the pace of the whole class that you don't have enough time to do a bunch of iteration
Right.
practice, I guess.
Yeah. So one year I went slower, but then we like barely covered all of the content.
Well, I get why. I think it's
Yeah, it's just AP. So I actually was talking to a couple teachers about this yesterday, just about like AP courses in general and how it feels like AP should like not exist and like we should just do college credit plus for all of the courses. But because college credit plus, you're guaranteed credit as long as you pass the class. they grant you college credit. Whereas AP, for whatever reason, I don't know. I guess AP is like more distinguished or something like that. Like AP Calculus is still like the dominant um, way to get college credit for calculus. But if there was a college credit plus, which those are through like COTC has options for college credit plus for several courses, so like Comp 1 and Comp 2. Those are college credit plus through COTC, but they don't have like a college credit plus calculus where like you wouldn't have to teach so much to the test. You could just like teach the calculus content, and if you pass the class, then you get credit for Calc 1 in college. But the AP, I guess, is a little bit more standardized across the board, whereas like pretty much any college will give you credit if you pass the AP test. So it's a little more rigorous than.
I honestly think it's better to keep a faster pace in middle class because, like, if you go slow, then you just won't be able to like teach an initial part of like understanding, and the rest is really just taking it upon the student to just.
Right. Yeah, you just gotta do it on your own. Yeah. It's not for every student either. That's in a traditional class. If students aren't completely getting it, or whatever, you don't go on to the next thing.
It really does move when the student took it into
Which is how college is. College, some of my math classes, like they would give you suggested assignments, and a couple of them, I didn't even have to turn them in. Generally, I did have to turn them in, but there's a couple where I didn't have to turn in assignments at all. Just like, hey, I would recommend you do these for practice. Yeah. I was, I don't know if you guys remember this, but on Wednesday, we finished with this one problem, and we were solving for the C, and it ended up being a negative. Here, I don't know if you guys remember that. It was right when the bell was ringing. We were solving for this. And it was like the natural arc is negative. It actually, I just looked, it actually is correct. We just need to do the absolute value of the natural arc. And so it just becomes just the natural log of the answer. And then when you plug it in, it actually works okay, because when you do the x e to the natural log of absolute value of negative 3/2, these cancel anyhow, so it actually just leaves with negative 3/2 x plus 2 is your answer. Another thing I was like just thinking about in kind of regards to this problem, not thinking about the absolute value, is when you need to remember to use the absolute values on natural logs, because that's another thing that seems kind of like fuzzy as far as the AP. And for these, this is indefinite integration, meaning like we don't know what the C is when we integrate it. So pretty much anytime you integrate something, just include the absolute values, because it's basically saying we don't know if it's positive or negative. So it's just a good idea to always include the absolute values, because it's an indefinite integration. And do you guys ever read like message boards or anything? Like you Google a question. I thought this was kind of funny. I was just curious about like if there was anything like AP related, like when you need the absolute values or whatever. And so I ended up on this Math Stack Exchange website where somebody kind of asked this question, and the answer, it was kind of funny. This one guy says, he was asking the question about the absolute value, and this one guy says, I always thought that the absolute value in this kind of context are, quote, niceties to ensure that the value isn't negative and there's no need to pay too much attention to them. And the next person comments, not trying to sound rude, but I don't want niceties. I need pure mathematical reasoning. Otherwise, I got myself. Well, that was kind of funny. And made me laugh. This message board is going to be kind of funny.
Yeah. You look at those a lot when you get into so
Right.
you say 90% on the
Yeah.
Darwin's view to racial selection.
Yeah.
This is yellow.
Yeah, they,
Just don't want to sound rude, but I don't want niceties. I mean pure mathematical reasoning.
I could just see him doing this, like, putting up his glasses.
Right. All right. So one last thing I want to do here, and this is actually the end of this section. But something that you can be asked, like if you think back to algebra, is like, is a number a solution to this equation? Okay. So like, if you remember, we did this in pre-calc, where like you're given this equation, you can't necessarily solve this equation, and this is not something that we could solve because you can't factor it or whatever. But you could answer something like, is this number a solution to this equation? Okay. So how would you answer that question? Is -2 a solution to this equation?
Plug it in.
Yeah, plug it in and see if it works, right?
If it's not zero, then it doesn't work.
Right, yeah. So we're going to use that basic concept for a couple problems here. So you plug it in, you get -8 plus 4 plus 4, 0, and 0. Okay, so yes, it's a solution. So we're going to do the same concept with this problem here, this last example of this section. And that is this equation, I believe, it's a lot harder than what we just answered, right? Is this equation a solution to this differential equation? Okay. So is this y equals something, is it a solution of this differential equation? So we're going to do the same concept. We're going to take this differential equation and we're going to substitute this in. Okay, so this is a y, so it's going to go in for the y. But in addition, we also have to replace y prime as well. So we're going to make two substitutions. We're going to replace y with y, what we're saying y is. And then we also have to replace y prime with what y prime is. And we can find the derivative of this. So that's the first thing we're going to do is differentiate this. Find y prime. The derivative of e to the x is e to the x. So it's 1/2 e to the x. And then the derivative of e to the negative x would be e to the negative x times -1. So it just comes to negative e to the negative x. And that's y prime. And then, so we're going to substitute y prime and y into this differential equation and see if they're equal. So we got 1/2 e to the x minus e to the negative x equal to e to the x minus, and then the whole quantity of y. So 1/2 e to the x plus e to the negative x. So let's just leave the left side. Go ahead and distribute this, e to the x minus 1/2 e to the x minus e to the negative x. Alright, and then looking for like terms, they have to have the same exponent to be like terms. These two do have the same exponent. Right, they're both e to the x. So 1 e to the x minus 1/2 e to the x would then be 1/2 e to the x minus e to the negative x, which is what we have on the other side. So which part? This
Like really towards the beginning.
the setup here. So if I write out the original equation. So here's the original equation. We found y prime first, so that we could plug it in for y prime. So that's right here. And then the y in the initial equation is what it gives you here. It's saying, is this y a solution? So we replace y with what we're testing for the solution. it would just be like saying, if this was a minus x is, x equal to a solution, so we plug whatever that is for that. And then the additional thing we have to do is for y prime, we have to find y prime. Like that. Let's see if we have time to do one of the assignment ones. Okay. Okay. So yeah, what you guys are going to be doing is numbers 10 to 13, and we can do one of those really quick. And actually, we need to do 10 through 16 this weekend for Tuesday. There's a couple of practice of derivatives there too. So you were saying e's and natural logs, it's a big deal to practice with that too. But let's do this first one real quick, number 10. So we're supposed to decide if any of these are solutions to this differential equation. So we actually have to do a second derivative because it's a y double prime. So we're going to do y prime, derivative of sine is cosine. So it's going to be cosine of 3x and then times 3. So it'd be 3 cosine of 3x. And then y double prime is then going to be minus 9 sine of 3x. Just go with that. And then the differential equation is y double prime, so y double prime minus 9y equals 0. So we're going to replace y double prime with negative 9 sine of 3x minus 9 times y, which we use the original y there, which is the sine of 3x. And see if that equals 0. And that would be a no, because we get negative 18 sine of 3x. If you just miss one of the signs when you're differentiating, then it would be end up getting yes. So you just got to make sure, because derivative of sine is positive cosine, then cosine is minus sine. So you get the minus. Alright. So you're just going to do that for these other three, see if you end up getting a solution. So find the second derivative, and then replace y in the second derivative with the differential equation. No school Monday, so see you on Tuesday.
We'll do
You can actually keep that.